Let's talk about. Okay. Yesterday we talked about significant figures. Significant figures are important in science, engineering, and engineering. Okay, because anytime you measure anything, depends on the quality of your instrument, it's going to have some built-in error. More expensive the instrument, better precision, more sig figs. Just like the example I gave you yesterday of my digital scale at home versus a digital scale in our labs. Digital scales in our labs are $500 or something like that. The one I have at home is $14. So gee, I guess you get what you pay for. So that's when significant figures come into play. However, if you're not measuring something, what are the sig figs then? Okay, now tomorrow or lab 2, I'm going to print off the data sheet conversions for you because the one in your lab packet is lousy, and I redid it all so that it's better in my opinion. Okay, so what do we mean by exact numbers? This is a tough one. How many are in a dozen? 12. 12.1? 11.9? No, exactly 12 by definition. So who knows what the sig figs are for that 12? Is it 2? I'm setting you up, obviously. It's not 2. It's infinite because it's not measured. How many times I have to guess? 3 times. It's not measured. It's exactly 3. So that 3, instead of being 1 sig fig, is infinite. So anything defined, like a dozen, what is it, feet in a 5280, whatever, it is. All the metric system, those are all defined. 1,000 meters to a kilometer, infinite as a conversion factor. Anyway, we'll be getting into that a lot starting tomorrow and Thursday. But exact versus measure. So just think in your head, is this by definition? If it's by definition, infinite. Now, when we start in Unit 2 on balancing equations, there's some coefficients there, and those are also exact. So those coefficients are infinite sig figs. Because when we start calculating things, the things that have infinite significant figures are not going to come into play because we always have to pick the smaller one, and everything is smaller than infinite. And it'll make sense a little later today. Okay, so that makes sense on the measured versus exact numbers. I didn't cover that yesterday. Okay, the other thing I didn't cover yesterday, I mean, I covered it, but there's 2 ways to do it. One of the when we get into scientific notation, we had it's 2 parts. This is from 1 to 9.999, and this is a plus or minus exponent. That's standard notation. One of the activities in lab 1 is convert the improper scientific notation number to the proper one. I gave you an example of that yesterday, but there are 2 ways to do it. And yesterday, most of you did it the way I didn't show you in class. So I'm going to do it another way. So let's have something like 127 times 10 to the 4th. Okay, so that's an improper scientific notation. You always have to have proper notation when you're talking about scientific notation. So the first thing you do is you have to convert this to a number from 1 to 9.9. So it'd be 1.27. So the way I was showing you yesterday is one way. And okay, so this is the way I showed you yesterday. So what do you do when to convert 127 to 1.27? You have to divide by 100. So that means we have to multiply the exponential by 100. So it's the same number. So that makes that 10 to the 6. That's the way I showed you yesterday. No one did that yesterday in lab. But that's a very valid way to do it. The other way to do it is to do an intermediate step, was to convert this to a non-scientific notation number, to be 127 that. Then from there, take it to the proper scientific notation number. So this would be 1.27, 1, 2, 3, 4, 5, 6. 6. So that's the other way to do those problems. And everyone yesterday just did them intuitively the second way. So does that make sense? So just convert it to the long way and then convert it back to the proper scientific version. Okay, so those are two things yesterday I didn't go over that in lab I was going, forgot to cover those. Okay, does that make sense? All right. So let's now jump over to how to do a lab write-up. Now, the way I'm going to show you how to do a lab write-up is, I was just talking to another instructor who's in room 104. Or actually, she's in 106. And I was asking her about lab notebook. And she said, I do everything digitally. And I said, well, I allow my students to do it too. It's just that I wanted to show them if they wanted to do it kind of old school way. She says, no, don't have it. So what we're going to do is, now the purpose of the lab write-up, everyone thinks it's busy work in the beginning, and after a while they see the error of their ways and they say, oh, I'm much more organized now than I would have been. Some classes, like at Sac City, the 2A equivalent class, is they don't have a lab notebook. They just have a worksheet and you just fill in the blanks. And students don't even know what lab they're doing until they walk into the lab. That's not me at all. I want my students to be prepared, organized when they walk into the lab for two reasons. One, you're organized and you get out of there on time. And secondly, you work in a safe environment. Safety is paramount in lab. Even though labs in Chem A are very safe, the more chemistry you take, they get less and less safe. So when you're taking advanced organic chemistry, you're working with a whole bunch of BA chemicals. Who knows what BA stands for? Who's been in the service? What does BA stand for? Badass. That's right. I knew you would know. Just like, how about fig mode? Fig mode. F-it, I got my orders. He was in the Air Force. I was in the Air Force too. And then, of course, there's FUBAR. FUBAR. All right. So sorry. The slide. Okay. See what happens? I lost track. What was I talking about? Oh yeah. As you go into higher levels of chemistry, the chemicals become very, very higher risk. For example, you use a lot of concentrated acids. We don't in this class. My organic class, we do use concentrated acids. I mean, for example, on hydrochloric acid, you take the top off and it smokes. Bad stuff. A lot of oxidizing agents, very strong. So you've got to wear gloves and all that stuff. So lab safety is extremely important. And because again, I tell you, I've not had any accidents. Okay, so that's one of the reasons you're doing the lab write-up, as detailed as it is. Okay, so these are the parts of the lab write-up for the pre-lab. Okay, So those are the parts in a pre-lab. So, title of the lab. Now I'm going to show you this as an example. This is a lab we did in up in Tacoma. This is a really good lab. I'm going to try to get this lab introduced into Chem A for next year or the year after. Anyway, so we have to have the title of the lab. That's kind of like duh, right? The next thing we have to have is purpose. Why are we doing the lab? Now, every lab write-up you get in your lab packet on almost all courses has a background. And the background talks about the concepts in the lab and also what the lab's about, also the lab setup and that kind of stuff. So that's where you find your purpose, is in the background. You just read it through. Why are we doing this lab? Like lab next week, the first one, lab 3 on density. Learn about lab procedures to learn about what is density. I mean, that would be the purpose. Understand density or something like that. Very simple. I don't want 5 paragraphs. Also, don't write the background unless you want to write the background in your lab book. It's perfectly fine, but I'm just not required. Some people like to do it though. It's just kind of a way for them to kind of study. So it's fine to put it in there. Okay, the other thing is procedure. Now think of a recipe. How do you make bread? Okay. First thing on the recipe are materials. You need flour, you need yeast, you need water, and a skilled baker. Okay, so materials. It's part of procedures. And you can put the materials before or after procedure, as long as they're there. Then the procedure. Just like in a recipe, you've got steps to follow. What do you do first? Typically, you preset your oven to a certain degree. That's procedure step number 1. Step number 2 is you mix your dry ingredients together. Flour, salt, dry yeast. Okay, step 3 is you mix in your wet ingredients till no dry ingredients are seen. Same thing in a chemistry experiment. We have materials and procedure. Notice it's handwritten. Handwritten. Now, my handwriting is crappy. When I was in high school, I had perfect handwriting. As soon as I started going to college, I started going, I had to write really fast, taking notes and stuff. And now, not very good. So however you want to write, you can write cursive or print it. Either way, is fine with me. You can also summarize it as well. So you can do word for word, or you can summarize. In my opinion, it's better to summarize it because then I know you read it. If you go word for word, you don't necessarily understand what you're writing. That's why we don't use digital. It's because people weren't reading it. They were just copy, paste. That doesn't mean anything in terms of whether you understood the procedure or not. Okay, so you write off the procedure. Some labs are longer than others. Some are pretty short. Like next week's lab is a pretty short lab. Good first lab, but it's not very long. Okay, there's another example. Oh, by the way, there's 2 signatures on every lab. This is for pre-lab, and this is cleanup. So before you leave, show me where area, make sure it's clean. Then I'll give you your second signature. Before you start the lab, you need a pre-lab signature. So did you do the lab or not? Did you do the pre-lab or not? So that you can actually do the lab. If you don't do the pre-lab, now the first lab, I'm going to be, like I was telling you, you can fix everything. So if you don't do the pre-lab on the first lab, you can still do it. But from then on, if you don't do the pre-lab, you cannot do the lab. You can do the pre-lab later for partial credit, but it's easy points. It's 3 points out of 10. Okay, the other thing is first aid. The first 2 labs are using water only, so there's no first aid for water. After that, we're going to be getting into using, I think the second lab is percent composition. Third lab is the hydrate lab. And that you're going to be using copper sulfate. So you're going to have to look up the first aid for copper sulfate. Where do you find that? Find it online. So let me show you how to do that. Okay, so we're going to look up the first aid for copper sulfate. Now, there's something called SDS. SDS stands for Safety Data Sheet. Safety Data Sheet. Every manufacturer in the Western world, and most in the non-Western world, internationally have agreed to make up a SDS per chemical. So, bless you. Copper sulfate. There's an SDS on copper sulfate. So let's look up the copper sulfate SDS. Okay, so you only want to use the SDS for safety. Like safety data, okay, okay, now there's about 18 sections to every SDS. Section 4 is first aid. We're going to go down to section 4, first aid measures. That's the first aid for copper sulfate. Now, next week's wet lab is water. There's an SDS on water too. Believe it or not, as a prank from a high school student down in Santa Barbara. And he did it as a prank to the school board, and the school board bought it. It's really funny. The thing about water, think about it. If you don't get enough of it, you die. If you get too much of it, you die. So it's very unsafe chemical, right? If you think about it, okay. So, and the first aid stuff goes into eye contact, skin contact, ingestion, that kind of stuff. And you can abbreviate this if you want to. Now, you might think this is busy work. It's not. It's very important that you're exposed to the first aid on any chemicals we're using in this class. Now, if we have a copper sulfate come up later in another lab, all you need to say is C lab 2 or whatever. You don't have to rewrite it all. I want you to be safe, but I don't believe in busy work either. Okay? So another thing is for example, if you were looking up, some labs are going to have a lot of chemicals. But the first aid, for example, on copper sulfate, copper nitrate, copper acetate, those three have the same first aid. Don't write it 3 times. Just write the chemical each chemical with the same first aid. So if you want to write it 3 times, you may write it 3 times, but you don't have to. Okay? Because there's enough handwriting as it is. So does that make sense on how to find the first aid? SDS, only use the SDS though. Section 4 for first aid. Now, if you're pregnant, trying to become pregnant, or breastfeeding, you need to go to section 11 on toxicology. Will this cause birth defects? It's in this section here, section 11. Is this carcinogenic, will cause cancer. That's in this section here, toxicology. So if you're pregnant, breastfeeding, or trying to become pregnant, including guys, as it affects your sperm, hey, look at this section. Okay? I just want to protect your little one, even though it looks like I have a little one here. Okay, are there any questions about the first aid? Okay, now we're using water on the first two labs, so you don't have to write anything up to that. So no first aid. Okay, okay, data table. The purpose of a data table is a place to put anything you've observed or measured and to help you be organized. Now, how do you do a data table? Data tables come from the procedure. So you read the procedure, and if the procedure says observe, was there a reaction? Yes or no? Data table. What is the mass of the new solid? Data table. What is the mass of your copper sulfate before you started? Data table. What is the mass of the empty beaker? Data, that kind of stuff. So those are the parts of the pre-lab. Title, purpose, materials, procedure, first aid, if any, and then a data table. And the data table can change. So don't worry if you didn't add enough spaces or whatever, just start one and then change it as you go if needed. Okay, so are there any questions about lab write-up? Okay, and it's due the day of the lab, before the lab starts, not during lab. Okay? If you didn't do a pre-lab and you go out to the hallway and do the pre-lab, come back in, you still cannot do the lab. It's going to take you, a good half an hour minimum to do the pre-lab. By that time, your partner's all pissed off at you because you didn't do it. By the way, Tuesday, folks are going to choose a lab partner today. And we're and then tomorrow and Thursday, we're going to do your actual drawer. Check through it, stuff. Okay, another thing in science. Numbers have units. Very few numbers in science don't have an associated unit. pH, for example, doesn't have a unit. pH is a measure of acidity. Doesn't have a unit. Most numbers, though, have units. Could be degrees Celsius, it could be degrees Kelvin, could be grams, kilograms, whatever. Make sure your data table has units on it. And there's two ways to do it. You can put the unit at the top. For example, this could be drops. Instead of writing all this time here, this could be degrees C. This could be seconds. Just make sure the number is associated with a unit for completeness. Now, when you go to your next chemistry class, it's the same thing. 2A is the most variable, but for 1A and 3A, this is it. Very standard. Unless you have the new teacher, the one I was just talking to, she does it all digitally. I do it digitally too, just make sure it's handwritten. Okay, are there any questions about the write-up? Yeah.
Do we do this for my hand?
Good question. Wet labs only. Wet labs only. So that's why this week we're fine. Next week is your first wet lab. Sure. Okay. All right. So let's. Now, you're given a week to do a lab, minimum of a week. I usually give you more, but minimum, you'll have at least a week to do it. That is going to be, there's three parts of doing a lab. pre-lab, do the lab, and then write it up, finish it up and upload it. Okay, when you upload it, there are questions, post-lab questions, and a conclusion. Conclusion is really short. I don't expect 2 pages of conclusion. All I expect is a good solid paragraph. I didn't scan her conclusion, but anyway, a conclusion is pretty, pretty, what did you learn? That's all I want. Usually about 3-4 sentences, no paragraphs, no pages, nothing like that. Make sure it's in it though, because you'll get dinged for conclusion points. Also, if you make an error, now the OCD folks in the audience here are going to want to use whiteout or erase it, whatever. No, no, no. I have to be able to see everything on your notebook, including errors. So if you white out your error, I won't know what it was. You put a simple line through it, like this, so I can read it. And if you're OCD, make sure it's totally level and in the same spot every single time. My second wife was OCD, big time. Stories I can tell you about OCD. It's great if you're an employee, not great if you're a spouse. Let's see. Okay, your notebooks are going to be done in pen, blue or black for most teachers. I allow color. I like color. So in my class, you can use blue or black. You can also use color highlighter, pink ink, whatever you want. That's fine. But a lot of teachers only want blue or black. Just their preference. So just expect when you go to the next class. Okay. Now there are questions. Sometimes there are pre-lab questions, sometimes they're not. If there are pre-lab questions, that needs to go in the pre-lab. So on your wet lab next week, there's a section called pre-lab. Those are pre-lab questions, not the whole pre-lab. That's part of the pre-lab, okay? So everyone thinks answering those pre-lab questions is doing the pre-lab. No, that's only part of doing the pre-lab. Some have them, some don't. This depends on who wrote the lab. There's always post-lab questions and calculations, though. And there's always going to be a conclusion, even if the lab does not say, write a conclusion. All the labs that I produce always say that at the end. The other thing they may say is, discuss your results or something like that. That's the same thing as a conclusion. You just need something to bring it all together at the end. Okay. Now, there are videos of this from past semesters as well. Okay, so I'm going to stop this video and